Bonjour tout le monde. I'm Yongta Lin from National Taiwan University. It's happy to be here to introduce our work outside in, visualizing out-of-sight regions of interest in a 360 video using spatial picture-in-picture previews. 360 videos is the new trend for sharing. It provides an omnidirectional record that really captures all the surroundings in that moment. However, in viewing this wide content, we can still watch it with a limited field of view in order to get a natural projection. This limitation leads to search problems and can be severe when numbers of regions of interest grows. Just like the clip shows, after a long search, we think we finally find something important, but at the same time, we are missing other regions of interest at the same time. Therefore, our goal is to visualizing them for effective navigation, and we can watch an all and catch an all. Now let's talk about the related work. First, I will introduce the traditional way in visualizing off-screen targets. A decade ago, many works focused on visualizing out-of-sight targets for navigating map on a mobile device. However, they don't provide the content of the region of interest. For the high diversity scenario like 360 video, we think providing preview is essential. In the field of multiple camera surveillance, the arrangement of picture-in-picture have been widely explored. They visualize both position and content of the target, especially the video plan proposed in a contextualized video further inspires the design of outside in. Now I will introduce the recent works on panoramic content. To address the limited field of view, some works focus on expanding the field of view. Others provide explicit hints to the users. However, these works have the limitations such as needing extra devices, interrupting the user's browsing experience, or having the limited scenarios like only suitable for videos with single region of interest. Next, the design. To remind you, our motivation is for effective navigation. Before implementing, we come up with 3 design considerations. The first one is minimizing the impact to the main content. Visual cues should not steal the show and should be placed in the peripheral regions. Second, the design should effectively guide the user towards the target. To do so, the spatial hint should contain both directional and distance information. It should be easy to learn as well. Last, the design should have previews of context since the meanings of regions of interest diverse and also subjective among the viewers. So the design question becomes, how do we place the picture-in-picture on the main screen? The outcome is like this video. And behind the scene, the algorithm applied on the picture-in-picture can be divided into 2 sections, the directional guidance and the distance guidance. First, the directional guidance. The guidance tells the viewers which direction the regions of interest is located at. So how do we calculate the direction? This is the flight path I flew here from Taiwan to Canada. The Great Circle route is the shortest path, the most fuel-efficient path on the spherical surface. However, is it the best path in guiding viewers? Putting picture-in-picture on this path can guide viewers in the shortest way. For the left-hand side, the viewer is watching a 360 video. The green area is his field of view, and the star represents the region of interest. As for the right-hand side, the rectangle is the viewport, and the arrow is the visual cue. The arrow is put on the shortest path from the center of a viewport to the regions of interest. When the regions of interest runs behind the viewer, the arrow runs downside of the viewport. When the region of interest is right behind the viewer, the arrow is guiding the viewer, the region of interest is right below him. The viewer can still find the star, but his neck is aching. Instead of viewing in an upward angle, we unwrap the sphere into an equirectangular projection. This form is also the way that 360 videos are commonly stored. We put the visual cues on the connection from the center of the viewport to the out-of-sight region of interest. And putting picture on this path can guide the viewers in a more comfortable way. And here's the outcome. The arrow won't go through the downside of the viewport. As a result, when the region of interest is right behind the viewer, he can follow the cue, turning left to see the target. Now we put the picture-in-picture on the right direction. To strengthen the directional guidance, we further rotate the picture-in-picture, making it like an arrow pointing toward the target. Worth noting that, for the sake of readability, the horizon in the picture-in-picture stays horizontal during the rotation. And this is the outcome, and we can see the picture-in-picture acts like an arrow pointing towards the outside UFO. And upon the rotation, the scene inside the picture-in-picture stays horizontal. Second, the distance guidance. This guidance tells how far should the user navigate to. How do we calculate the distance? Aforementioned picture-in-picture is put at the connection from the center of a viewport to the regions of interest. We make use of this line as the region of interest distance. It's the hypotenuse of the triangle which combines the effect of vertical and horizontal differences. Then how do we visualize the distance? Here we make use of the perspective effect. When people see a tilted plane in the space, they have the instinct to change their line of sight in order to have a less tilted view. We use tilt to show the distance. The tilt angle is calculated by linearly mapping the distance value. The maximum extent of the tilt angle, which retains the readability, as decided through a pilot study. Like in this animation, when the region of interest is approaching, the picture-in-picture is gradually facing to the viewer. Tilt also makes the picture-in-picture blend into the scene, providing better immersive experience. Without the tilt, picture-in-picture scenes like photos scatter on the viewport, which degrades the viewing experience. Here's the outcome. When the viewer navigates towards the target, the tilt of picture-in-picture gradually changes and guides the viewer to the target. Now it sounds perfect while picture-in-picture are placed in a limited space. Also, the directional connection can overlap. When two picture-in-picture overlaps, the visual guidance is out of order. So how to resolve this issue? It's the figure behind the scene. Picture-in-picture is a 3D plane that floats between the spherical content and the viewport. To deal with mutual occlusion, we introduce another factor, depth. After mapping distance to the depth of the picture-in-picture, when the region of interest approaching the center of a viewport, the picture-in-picture moves in the same direction. With the help of perspective projection, the picture-in-picture with depth can be repositioned based on their distance, and viewers can learn the spatial relationship through the arrangement of the picture-in-picture. And this is the final appearance of outside-in design. Next is the user study. We want to know if the technique is helpful, so we investigate the behavior of using outside-in comparison to the traditional arrow-based guidance. For the 360 videos used in the studies, we categorize the 360 videos to 6 types based on their number of regions of interest and their motion. And single regions of interest cases are disregarded since the search problem is more severe in multiple regions of interest scenarios. In the end, we choose 3 representative videos from YouTube. For type C, we choose Pokemon video, in which multiple Pokemons appear at the same time. For type D, we choose help video, made by Google Spotlight, features a tracing theme. For type E, we choose Scroll of Rock video, in which a teacher and group of students are playing instruments around the camera. For the interfaces for the studies, the arrow borrows the algorithm of outside-in, but it has only the directional information and always locates on the border. We recruit 18 users from the college and use our iPhone 6s for viewing 360 videos. In the process, the procedure starts with a practice session. Afterwards, 3 videos are cut into 3 one-minute clips, and users always start a video with no guidance interface. After watching arrow or outside in, they are asked to share their experience and fill the questionnaire. The order of interfaces and video clips are counterbalanced. The whole procedure lasts for 1 hour. In the questionnaire, 4 rating questions are asked. The first one is the interference level. After running two-way ANOVA, we found there's no significance between these 2 interfaces. The second question is about the spatial perception. After the statistical analysis, outside-in outperforms arrow. The third question is about the awareness of storyline. Again, outside-in has a better rating than the arrows. The last question is about the preference. As we can see from the result, users prefer outside-in over the arrows. In conclusion, outside-in has a similar effect on interference, while greatly help people in watching 360 videos in different aspects with compared to arrows. Qualitative feedback is transcribed into 606 quotes, and we then code them iteratively and find out the things. For using the arrows, some users said it's easier to search, while some said it's confused because they don't know what it refers to. Some of them felt distraction because they cannot dismiss the arrows, which is always trying to tell you there's something important. In the end, some users give up on following the guidance and totally ignore them. For using the outside-in, some users report that it helps them capture the story faster. Because of the previews, they can choose to concentrate on what is important to them. As a result, some of them can make decisions and develop a better watching strategies. The spatial hints also help them perceive the spatial relationship. Last, the distraction raised by the preview window would become disturbing when the scene is complicated. In conclusion, what we learned from the user studies are traditional guidance is not enough, especially when there are multiple regions of interest. Last, even professional video needs the guidance. Next, the applications. First, we designed 5 gesture inputs on touch screens. When you tap on the picture-in-picture, the camera will automatically bring you to the selected scene. And you can also pinch in or pinch out to show hide all the picture-in-pictures. Lastly, you can use swipe or long press to dismiss one or focus one. Second, we integrate the interface into a telemeeting scenario in which the remote user can use outside-in to expand her awareness of the local attendees. The device represents the remote user, includes a 360 camera and a turnable screen. The device will sit in the center of the table. The remote user will control it through the interface of outside-in. With the help of outside-in, she can learn who's around her and interacting with her. And when there's a newcomer, she can find him through the emergent picture-in-picture. And next, the discussion. This work focuses on visualization techniques, so the regions of interest in the study videos are labeled manually, while in the telemeeting application, regions of interest are automatically chosen by face detection. In the future, we are looking forward to see other methods like video saliency or object recognition through deep learning. From the study, we found outside-in can be used in a variety type of videos. However, some videos with specific purposes are giving you surprise like horror movie or a treasure hunting video like Finding Valley. In such cases, providing previews will definitely degrade the watching experience. In this paper, we didn't identify the suitable types, so we encourage future researchers investigate the proper usage of outside-in. In our observation from the study and interview, watching behaviors varies from person to person. For example, in the recorded video, participant 12 follows the picture-in-pictures and finds the target. On the contrary, participant 9 starts to explore somewhere else. With the help of picture-in-pictures, he felt nothing to miss. Adding visual cues on the main screen must cause inevitable visual distraction, and we also identified that the distraction level is higher than the arrow, but there's no significance. In our implementation, size of picture-in-picture and depth range remain flexible for different kinds of situations. We also provide the function to show high picture-in-pictures in gesture input. In this paper, we use smartphone as the platform to watch 360 videos, since it's the dominant way to watch these 360 videos. In the future, we are looking forward to integrate these interfaces into a head-mounted display. The tier meeting application also inspires us on applying outside-in the social VR scenarios. Finally, the conclusion. I identify our contribution as follows. First, we propose this novel visualization technique. Second, we conduct a user study and learned outside-in outperforms traditional arrow. Third, we implemented 2 applications. And that's all. Merci pour votre attention.
Hi, Junior Lee from KAIST, South Korea. It's a very interesting talk. And I find the concept of mapping the distance to tilt very interesting. I just have one kind of, question or suggestion. Have you considered more gradually transitioning when the picture-in-picture reaches the destination? I mean, it seems now that the picture-in-picture is disappearing very abruptly. Have you considered maybe scaling or making it gradually more transparent so that it makes a transition more easier and maybe easier to look at?
Oh, okay. Great questions, great suggestion of the transition. And yes, we now the current version is interruptedly disappear when the region of interest enters the screen. And in the future, we are looking forward to do some transition or the training to make the experience even better. Thank you.
So I'm wondering if you can comment a little bit on how the type of scene affects the technique. So it seems like if you have a very busy scene with lots going on, you might end up having lots of previews. Is that, I guess, I'm curious kind of your thoughts on the type of scene and how that impacts the technique.
Type C?
Type of scene, like how busy it is, how many moving objects there are, if there's lots of things.
For the type C, the regions of interest are static motion. So maybe you mean the more complicated situation.
Right.
Yeah. I think when the scene is really complicated, the region of interest is the number of regions of interest too large. The scene will be very complicated because there are a lot of picture-in-pictures. So I think a better way to do the visualization, maybe we can distinguish them into different importance levels. So some of them are not so important in the current time. They can be visualized, use the arrows, and left the most important, maybe the ranking 1, 2, 3, and using the picture-in-pictures. So the hybrid method can use the arrows plus the outside-in to deal with the complicated situations.